Assalamualaikum and hi everyone. So today we are going to continue with topic 3, which is on numeric data. In this topic, we will learn about identifiers, which is the name for classes, variables, constants, and also methods. And then the different types of data types, such as int, double, float, char, and also Boolean. We will also look at data conversion, where we try and convert data from one type to another through widening or narrowing. We will also cover arithmetic expressions, operators, increment and decrement operators, and also the math class. Then we will look at the scanner class, and finally a little bit of programming style and the use of escape sequences. The objective in this topic are to differentiate between identifiers, variables, constants, and also arithmetic expressions. And we should be able to apply primitive data types and also to apply and analyze the operator in arithmetic expression, and also to use the math class, which we have seen in the class before. So what is an identifier? Identifier refers to the name of a class, name of a variable, name of a constant, and also the name of a method. Some identifiers are predefined while others are defined by the users. We are going to look into variables and constant in the next few slides. In this slide here, you can see that some examples of identifiers such as num1 or number, and any constant, for example here pi, and also for method, for example count number. By convention, variable names start with a lowercase letter. Class name starts with an uppercase letter. Constant's name would be everything in uppercase. By now we are slightly familiar with class name, where we have been writing several classes during our lessons. We know that to write a Java program, we need to write the class header, then we can have 0 or more methods. For example, we have this program. So we have public class example. So example is an identifier. It is the name of our class. And you can see that example E is in capital letter. Then in the next line, we have our main method. Right? So we have public static void main string args. So main is an identifier. It is the name of the method. And then we have int number equal to 0. The word number over here, that is the identifier of a variable. And then in the next line, we have final double pi equal to 3.14. So the word pi is the identifier of a constant. From this example, you can see that the class name example start with an uppercase E, variable number is lowercase letter, and constant pi is in all capital letters. What if I do it differently? For example, what if I wrote my program as shown in the blue box? Is it valid? Can I run it? What do you think the output that I will get if I run this code? If I run it, I will still get the same answer, the same output as if I run the one in the yellow box. Only that by convention, meaning that it is widely used and known that we will start our class name with capital letter, constant names all in capital letters, and variable name starts with a lowercase. It can get confusing in the middle of the code if say that you have the variable number in all capital letters, where other programmers, when they see your code, they will assume that that is a constant even though it is not. There are several rules for identifiers in Java. This slide lists out some of those rules. So the first one, it says it can be made of only letters, digits, underscore, and also the $sign. And then for your identifiers, it cannot start with a digit, and also spaces are not permitted inside the identifiers. In Java, there are reserved words that Java use. We cannot use reserved words as the identifiers. Let's look at the skeleton of a Java program. From here, we can see several reserved words that we cannot use as identifiers, such as public, class, static, void, and also string. What about the word example, main, and also args? Do you think that we can use those as our identifiers? Yes, we can use those words. So example is the identifier of the class, main is the identifier of the method, and args is an identifier for a variable. Continuing with the other rules, so an identifier cannot be true, false, or null. They are also case sensitive. We have seen this in our lab 1 where we have capital T and we know when we run our code that capital T is not the same as small letter t. An identifier can also be of any length. So it can be a long word or a short word. For example, x, or we can have length of circle. This slide shows some of the other Java reserved words that we cannot use as identifiers. So when we learn to write a lot more in our program, then you will see a lot more of these keywords. Let's quickly try this exercise. Can this be used as identifiers? Which of these are invalid? We cannot use number 3, hello, punctuation mark. We cannot also use 1 plus 2 because of the plus sign. And then second, which is number 5, because we know from the rule that it cannot start with a digit. And also number 7, because public is a Java reserved word. Public with the capital P is valid as it is not the reserved word. Java is case sensitive, so even though both are called public, the uppercase and lowercase of P makes it as two different things. Data types. So what is a data type? It is a set of values together with a set of operations. Primitive data types are the fundamental data types in Java. There are 8 primitive data types where we can separate it into 3 main categories, where there are 5 integral types, 2 floating point types, and 1 Boolean. Integral data types deals with integers or numbers without the decimal part. It can be char, characters, byte, short, int, or long. The differences among these are in terms of the memory they used and also the range of values which will be shown in the next few slides. Floating point data types deals with decimal numbers. We will see float and double. Boolean, on the other hand, deals with logical values. So a Boolean has 2 values, either true or false. This slide shows the different types, the kind of value, memory used, and the values range. It depends on the precision and how big the values that you want and need to have in your program. For example, we can compare byte and short, where byte has the range from -128 until 127, while short covers from -32,768 to 32,767, meaning that it covers larger numbers. In terms of the memory used to store each of the data type, whichever type that you choose to use in your program, if you don't really make use of it, it will just be a waste of memory. It doesn't matter much in our current computers as we are not using all of our memory. But if we have limited memory, then this is useful to know before writing the code. Byte data type only takes 1 byte or 8 bits, while short data type takes 2 bytes or 16 bits memory. Characters. A char variable stores a single character. Character literals are delimited by single quotes. As shown in the example here, we have single quote A closing the single quote. How to use char? Example here, it shows char top grade equal in the single quote the letter A. Char is the data type of a variable. String, on the other hand, is an object. So the difference between a primitive character variable which holds only one character, and a string object, which can hold multiple characters. In a string, we use double quotes. Char uses single quotes. A character set is an ordered list of characters, with each character corresponding to a unique number. A char variable in Java can store any character from the Unicode character set. The Unicode character set uses 16 bits per character, allowing for 65,536 unique characters. It is an international character set containing symbols and characters from many world languages. We have looked at the ASCII table in topic 1. You can refer to the table to see the characters that it contains. The ASCII character set is older and smaller than Unicode, but it is still quite popular. The ASCII characters are a subset of the Unicode character set, including the uppercase letters, lowercase letters, punctuation, digits, special symbols, and also control characters. Now, let's look at Boolean. A Boolean value represents a true or false condition. The reserved words true and false are the only valid values for a Boolean type. For example, Boolean done equal to false. You don't have to write double quotes because Boolean has the value true or false. If you use double quotes, that means that is not a Boolean, but instead that is a string object. A Boolean variable can also be used to represent any two states, such as a light bulb being on or off, as we can set it as true or false. Variables. A variable is a name for a location in memory that holds a value. It is used to store data input, data output, or intermediate data. Variables can represent data of certain types. We have looked at the 8 different primitive data types. The value of the variables may change during program execution, such as if you use it to do some kind of calculation, or if we initialize it to a different value after a few runs. To use a variable, it must be declared before it can be used. Declaring a variable tells the compiler to allocate appropriate memory space for the variable based on its data type. We also need to initialize it. How to initialize a variable? We will see how to do that in the next slide. The syntax to declare a variable is we have to write the data type that can be int, double, char, string, and many others, and then the variable name, which can be anything as long as it follows the identifiers rules. To declare several variables, we can write it in several lines or within one line. If they are of the same data type, we can write it within one line as shown here, int I, j. If we want to write it within 2 lines, we will write int I semicolon and then in the next line, int j semicolon. So that means that we have declared our variables called I and j. The important part to be aware of is if you write it in one line, you need to use the comma and you do not need to repeatedly write the data type. But if you write it within several lines, meaning that you declare all of the variables separately, you need to write the data type and then the variable name and end it with semicolon. When you declare the variable, you are actually specifying the variable's name and also the type of information that it will hold. In this slide, it shows that you can declare the variables within one line or several lines. Remember that in declaring variables, you need to have the data type followed by the variable name. From the previous slide, we have declared the variable without giving any values to it. A variable can be given an initial value in the declaration. For example, here we have int sum equal to 0. When we declare and initialize our variable, we can also write it within 2 lines where we can separate the declaration and initialization. For example, on the first line we write int sum, so we are declaring it. And then on the second line, we write sum equal to 0, where we give the initial value of 0 to the variable sum. For any variable with the same name, we can only declare it once. We will get an error if we try to declare it several times. For example, say that we have int sum, and then in the next line, int sum equal to 0. Is this valid? We will get an error if we try to compile this, where it will say that variable sum is already defined. We can initialize our variable anywhere and reassign it again to any value depending on what we want our code to do. So to make this code valid, you can write in the first line int sum, and then in the next line sum equal to 0. You don't have to write the data type again. Let's look at this code. Once we have declared our variable, we can initialize it anywhere and reassign it again depending on what we want our code to do. As shown in this code, in the beginning, we declared and straight away initialize it to 0. Then we display it on the screen using our system.out.println. In the next line, we reassign a new value to it, which is 100, sum equal to 100, and print it out using system.out.println sum. By doing it this way, we are reusing our variables, as we do not actually need to have two variables, but we can have several variables if that is needed in our program. When we reassign the value of the variable here, we cannot get the value 0 from previous initialization, as the value has been replaced by the value 100. So it all depends on what you want your program to do. When a variable is referenced in a program, its current value is used, so whatever latest value that you give to it. Let's look at this example. We have this class called piano keys. Here we have the int keys equal to 88. We have initialized our variable called keys to have the value 88, and then we do string concatenation in our print line. The sentence a piano has is within the double quotes, so that is a string. Keys in the middle refers to the variable that we declared and initialized before, and the word keys at the end is within the double quotes, so that is another string. When we run this code, we'll get the output a piano has 88 keys, where keys refers to the value of the variable. Now let's look at assignment statement. An assignment statement changes the value of a variable. The assignment operator is the equal sign. The syntax for it is variable equal expression. For example, if we have int total equal to 0, total equal to 55. The value that was in total is overwritten from 0 to 55. We can only assign a value to a variable that is consistent with the variable's declared type. That means we cannot have total equal to 1.2 because int cannot have any decimal point number. Let's look at this example here for the class called geometry. In the beginning, we declare and initialize int sides equal 7. Then we reassign sides to have the value of 10 and display the output. We reassign sides again to the value of 12 and display the output. What do you think will be displayed when we run this code? The output that we will get is as shown here. So we have a heptagon has 7 sides, decagon 10 sides, and also the 12 sides. We cannot get the value of 7 and 10 at the last system.out.println anymore because we have changed the value of the sides. So when we reassign the values, it replaced the previous value that it has. If we were to keep the value of 7 and 10, we can declare several variables. For example, we can have int side 1 equal to 7, int side 2 equal to 10, and int side 3 equal to 12. Then we can access all the values by calling the respective variables, which are side 1, side 2, and side 3. If we are only using the variable side 1, side 2, and side 3 only once, that means that we are just wasting memory when we can always reuse the same variable. In assigning values to the variables, we can also assign another variable to have the same value of another variable. For example, if we have int j equal to 10, int k equal to j, so that means k also has the value of 10. On this slide, it shows j equal to k equal to x equal to 6, which is equivalent to x equal to 6, k equal to x, which means k is also 6, and j equal to k, and since we know that k is 6, j is also 6. Uninitialized variables. Say that we have int lucky number, meaning that we have declared a variable called lucky number, and the data type is int. When we compile this code, it will not be able to compile, and we will have an error that says our lucky number variable have not been initialized. It makes sense because in the code, we have only declared a variable and print out a variable without giving it any valid value. There are cases where we do not have to initialize our variables, such as for class variables that have default values. But as what we have seen so far, we have only written local variables and we need to initialize them. So in this code, what do you think we should do to be able to compile and run this code? So what we should do is, at the first line, we can have int lucky number equal to 0 straight away. So that means that we have declared and initialized our variable called lucky number. A constant is an identifier that is similar to a variable, except that it holds the same value during its entire existence. As the name implies, it is constant, not variable. The compiler will issue an error if you try to change the value of a constant. Constant is a permanent data that never changes during program execution, which means you cannot change the value of a constant. That's why we wrote final in front of it, meaning that that's the final value. The syntax for a constant is the keyword final followed by the data type, the identifier, and the value of the constant. Any final constants can be used as part of any variable's calculation, only that the value of that constant that will never change. A simple example is, say that we have final double pi equal 3.14159. We know that the value pi will always be 3.14159, so it makes sense to have it as a constant instead of a variable. We can use that value to calculate the area of a circle and the area of a sphere by referring to the same constant without having to repeatedly type the same value. As I have mentioned previously, by convention, constants would use all in capital letters. Other example of constants, as you can see in this slide, we have final double centimeters per inch equal 2.54. In short, you can use constant for anything as long as you don't want to change that value at all during the program execution. Let's look at this example of a class called area of circle. It declares and initializes the constant pi, type double to the value 3.14. Similar to any calculation, the constant can be called and used at any part of the code. Here we have area equal to pi times r times r. When it does the calculation of the area, it will take the value of pi, which is 3.14, and the value of r, which is 5. From this code, we can see that since we initialize the constant pi and variable r, if we were to change the values, we only need to reassign the values once without having to replace it everywhere in the code. What I meant by that is, say that if we did not declare and initialize int r equal to 5, say that we don't have that line. That means to calculate the area, we have to write double area equal to pi times 5 times 5. If I decided that the radius should have the value of 10, then I have to go through my code and change my calculation. so that my area is now equal to pi times 10 times 10. By having variables, it simplifies my code where I only need to change and reassign any related values once. For example, I just need to change at r equal to 10 and that's it. So, all the other parts of my code will not change. To summarize, we have covered identifiers and the rules of it, the different primitive data types, declaring and initializing variables, and also constant, where in constant we need to have the keyword final as part in the syntax. That's all for the first part of this topic. In the next part, we will cover arithmetic expressions.